Hello everyone, in today's video we will be talking about triangles. We will first talk about the angles of triangles, then we will be talking about defining triangles based on their angles, and lastly defining triangles based on their sides. So here we are going to be categorizing triangles basically, depending on their angles here and here, depending on their sides. But before we do that, we need to begin by talking a little bit about the angles of a triangle. So here you can see that I've made a triangle, and I've given you two of its angles, but the third one remains unknown, and the same goes for this one as well. This is a classic exercise, basically, where you know two of the three angles and you want to find the third one. How you do that is you need to remember that the sum of the angles of a triangle, so basically if I add all three of these angles together, it needs to be 180, always. It can't be less, it can't be more, it needs to be exactly 180. And you can see that for yourself. Make any triangle you want with a ruler and then measure its angles. You will find 180 degrees altogether. So here, what that means is that if I add these three angles together, I need to get 180, which means that x plus 30 plus 100, so that's the sum of all the angles, needs to be 180. So this is an equation that I can solve quite easily by saying, well, then that means that x plus 130 is going to need to equal 180. And now I'm going to subtract 130 from both sides, so that's going to leave me with x being equal to 180 minus 130. Therefore, x is equal to 50. So that's how I can find uh, the last angle if I know the other two. Keep this in mind because you will see this exercise on your worksheets. Next up, we have the same thing going on here where we know that these two are 70 and we want to find this one. So we need to do x plus 70 plus 70 needs to be equal again to 180. So that means that 70 plus 70 makes 140. So x plus 140 needs to be equal to 180. So subtracting 140 from both sides, I get that x is equal to 180 minus 140. Therefore, x is equal to 40. And I haven't actually measured these angles, so it might not be exactly like that. But you can make a triangle on your own piece of paper, then measure the angles, and you will see the proof for yourself that, yeah, if I add all of its angles together, I get 180. Okay, next up, we want to define triangles based on their angles. So there are three categories for each type of definition. So three categories based on angles and three categories based on sides. For angles, the first category is having an acute triangle. In Greek, that would be oxygonio trigon. An acute triangle has all three of its angles being less than 90 degrees, being smaller than 90 degrees. If you look at all three of these angles here, you will see that they are smaller than 90 degrees. They are less than 90 degrees. They're very closed, all of them. My next category is the right triangle. The right triangle has one right angle, as you can see here by the little box that we said yesterday signifies a right angle. Well, a right triangle has exactly one of those. No triangle can have more than one, because again, we said that the sum of the angles needs to always be 180. So if we had, let's say, 2 right angles in a triangle, then that would be 90 plus 90 if this was a right angle, right? 90 plus 90 would make 180. But then the third angle, if I added that as well, then that would be more than 180, definitely. It can't be 0. That has no meaning. I wouldn't have a triangle like that. So if you have a right triangle, then that right triangle definitely must have 1 right angle and 2 acute angles. If you look at these 2 angles, they're definitely acute. Next up, we have a triangle with an obtuse angle. Right here, you can see that obtuse angle, meaning that it is more than 90 degrees. And an obtuse triangle or in Greek, ambigonio, has 1 obtuse angle right here and then 2 acute angles here and here. Okay. Next up, we're going to talk about triangles based on their sides. So here we have, when you see a triangle that has these little lines through its sides, what that means is that the sides with the lines through them are equal. So here, this side and this side are equal, whereas this side is different, the bottom side is different. And here, since all 3 sides have the line through them, and all 3 are equal. Here, where you see no lines through the sides, that means that all the sides are different, and you can see that just by looking at them. You can see that this one is really small, this one is really long, and this one is somewhere in between, right? So here we have no sides equal, here we have 2 sides equal, and here we have all 3 sides equal. When we have no sides equal, we call the triangle that we get a scalene triangle. In Greek, that would be scaleno. When we have 2 sides equal, that is called an isosceles triangle. In Greek, isosceles trigono. Lastly, when we have all 3 sides being equal, then we have an equilateral triangle. Or in Greek, isoplevro. Trigono. So again, equilateral means all 3 sides are the same. Isosceles means that 2 of the sides are the same, so this one and this one. And then scalene means that no sides are the same. And that is how I categorize triangles based on their sides. Here is how I categorize them based on their angles. And this is the very important information about how I find the third angle if I know the other 2 in a triangle. Again, because the sum of the 3 angles needs to be 180 always. So that'll be all for today. I will see you guys again in, well, on Friday's video actually. So have a good day.